Explanation of the evidence at the Pentagon on 9/11, created by Wayne Coste, narrated by David Chandler. Okay, here's the table of contents, and here's the table of contents for chapters 9 to 17. Chapter 4, Design, Construction, and Destruction of the E-ring exterior wall. The E-ring exterior wall is frequently a point of confusion. The wall that was present on 9/11/2001 is frequently referred to as massive and blast resistant. Little detailed analysis of the wall is available in 9/11 truth circles. Many who speak about the Pentagon repeat assertions of steel reinforced concrete. There is also no interior E-ring wall on the first floor. There are no walls on the first floor between the exterior E-ring and the interior wall for the C-ring, where some of the parts of the plane broke through into the AE drive. Review of construction prior to 9/11 shows modest wall mass, potentially 75 tons for a 100-foot span compared to a 100-ton impacting aircraft. The connections of the wall to upper and lower slab are relatively weak. It had 3/4-inch through-bolt connections, about 12 bolts per section between columns. The ground floor slab had 4-inch by 4-inch steel tubes that are inset into the ground slab. Many people have repeated, as Wayne Coste says he himself has, that the exterior walls were made of massive layers of concrete, brick, and limestone. But that is, in fact, not how these walls were built. There is no steel reinforced concrete. The walls that were replaced after 9/11/2001 appear to be much more massive, however. Here's a sketch of what they look like from the inside. Between the columns, there's a steel tube structure supporting the window frames and blast-resistant windows. The windows were designed to withstand bomb blasts and high-force lateral impacts, like the Khobar Tower bombing in Saudi Arabia in 1996. That was a U.S. Air Force housing complex that was attacked by a massive truck bomb, in which most of the deaths were caused by flying glass. So protecting against flying glass was the primary concern for the Pentagon. So let's look at the design criteria. In the article, Retrofitting the Pentagon for Blast Resistance, they say there is no reinforced concrete wall backing. The idea of supporting the brick infill walls with a reinforced concrete wall backing was rejected as a typical approach because of the Pentagon's extensive fenestration. That's a word that was referring to how many openings, like how many windows and so forth, there are in the wall. Instead, the selected approach was to use vertical tubes welded to the window frames at the top and bottom. The structure became the support for the blast-resistant windows. Then they gave additional blast protection to the brick infill portions of the wall. Namely, they covered it with Kevlar to keep the brick fragments from becoming shrapnel. To make the solution work, they used floor-to-ceiling tubes connected to horizontal plates at the top and bottom, which were on the second and third and fourth floors, connected to the corresponding plate in the floor above and below, with a 3/4-inch threaded rod. The idea was to make the total steel tube structure able to absorb the energy of a blast, which would not happen if the steel rods were simply bolted into the concrete, because they would tear out of the concrete. On the first floor, they needed a different approach because the bottom connection had nothing to connect to below the floor slab. So they drilled the floor slab and ran the vertical tubes through it so they would bear directly against the floor slab through a bearing plate. What was made blast resistant were the windows. The document says, under the renovation plan, the outer wall was reinforced with structural steel tubing to increase its lateral stability and provide support to new blast resistant windows. Okay, so let's look at the construction photos before 9/11. Here is the exterior E-ring wall on the second or higher floor. You can tell that's the case because you can see the bolts at the bottom through the floor plate that would connect with the next floor down. It has no concrete in the wall. Here's more detail up close. The tubes support the windows, not the wall. The brick layer of the wall is covered with Kevlar to protect it from creating shrapnel. Here's a close-up detail showing the bolted connections through the floor rails. Here are some more detailed construction photos to illustrate the design we've been talking about. Note the source link to the documents. Post 9/11 event photos. The post 9/11 photos show the same thing. Here's a shot from the inside. Notice the bricks are directly visible. There is no concrete layer. The steel support tubes, the steel window frames, the window frame fingers that hold the windows, and the Kevlar are all shown. Note that the window was not shattered, it was actually melted. Here's another view which also shows fiberglass insulation over the Kevlar. You can also see the brick layer exposed. Here's an exterior view that shows the steel window supports and the fingers that had previously been attached to the window frames. This is in the vicinity of column 9AA. This is outside in the vicinity of column 3. The column surface is partially shattered, showing the brick layer and the fingers holding the window frame in place. Here's another angle of the same column and window. Here is column 9AA and adjacent steel window frame tube during the early stages of cleanup. This speaks significantly to the dynamics during impact because the wing at this point did not penetrate the column, but it did significant damage to both the column and the adjacent steel tube. And we can infer that the column and adjacent steel tube did significant damage to the wing. This is another picture of the same thing. This photograph was shown in an earlier chapter also. The picture on the right shows the badly damaged column and the adjacent steel window support tube. This shows the nature of the 4x4 steel tube inset into the floor slab. And let's take a closer look at the collapsed wall photos. All components of the wall are clearly visible in the post-collapse photos. Limestone exterior sheathing, brick layer, support columns, steel window frame supports, and the blast-resistant windows. We have seen this picture before. All the components are here if you can pick them out of the clutter. Here you can see the blast-resistant windows, the 4-inch steel tube window frames, the limestone cornices, and notice the shattered stump of the tree that was in front of column 16. Here the detail we're focused on is the fact that the steel frames were not continuous between floors. They were separate but bolted together through the floors. You can see the misalignment of the two frames. This is where they would have been bolted through the slab. Here you can directly see the through bolts that once went through the slab with the concrete broken away. Here's another example where you can see the through bolts that pass through the floor slab with part of the slab broken away. In Chapter 5, we will focus on the tree at column 16.